In the following videos, I will highlight my construction calculators according to the Eero codes in an interesting way. I am excited to share with you my video about the automation of backlink calculation. With this program, you work smarter rather than lazier. You will follow the calculation procedure step by step, accompanied by explanation and detailed analysis at each stage of calculation. The main disadvantage of flange beams is that they are sensitive to buckling under certain loads. Additional calculations and proper design are required to ensure that the beams are adequately supported and reinforced to prevent buckling. In the next few minutes, I will show how to check a compression element for buckling. Buckling calculator for rolled flange beams. To start calculation, first we need to enter the following informations and dimensions: yield strength, design value of the compression force NED, length of the column in Y direction LCRY, length of the column in Z direction LCRZ. Then we have to choose the cross section by clicking the Open Down button. By this flange beams calculator, we can get the design properties of each cross-section from IPE80 to HE1000M. This flange beams calculator serves as an aid for backlink calculations. We use this calculator to avoid unnecessary, routine, and time-wasting calculation procedure. By clicking on up and down buttons of this calculator, we can easily obtain the design properties of rolled flange beams, starting from IP80 as the smallest to HE1000M as the highest and heavier profile. Here you follow the calculation procedure to determine design buckling resistance NBRD for the compression element. Buckling curve required to determine impression factor alpha. And here are the equations to determine the slenderness of the flexural buckling needed to determine the design buckling resistance. Classification needed to determine design buckling resistance of the cross-section. Flange class depends on the ratio between the CO flange and its thickness. Web class depends on the ratio between the C of web and its thickness. The highest class is taken as the class of the cross-section. As mentioned earlier, we can find the imperfection factor alpha from buckling curve of the cross-section. In the first instance, the buckling curve depends on the ratio between the height and the width of the cross-section. Then the thickness of the flange influences the determination of the buckling curve. We take HED 260 as an example to calculate the design buckling resistance in 3 steps according to the data and dimensions below. As mentioned earlier, we can determine the class of the cross-section by substituting the values of C, the thickness of the flange, and the thickness of the web into the classification equations. Then, we take the highest class as unfavorable value for the cross-section. To determine the buckling curve, first we have to find the ratio between the height and the width of the cross-section. Afterwards, from the flange thickness, we can choose the buckling curve in the Y and Z axis with the related imperfection factor. From the cross-section properties, yield strength Fy, design value of compression force, and the critical length in the Y-axis, we can find the buckling resistance NBRDY and the unity check in the Y direction. In the same way, We can determine buckling resistance, MBZRD, and the unity check of the cross-section in the Z direction. Precision and accuracy are essential features of our calculations. I am happy with the end result, and I will be even happier if you find it valuable and can make the most of it. I hope and try to make my work as accessible as possible to the relevant group, especially civil engineers and architects. Are you interested in this buckling calculator? You will receive it for free by email for a week as a spreadsheet version. If you want any further information, feel free to contact us at info@rasemengineering.com.